Here we are going to see naming inorganic compounds. It can be maybe a little difficult for you, but if you follow the rules that I'm going to show you today, you're not going to have any type of problem. Let's begin by binary compounds that are ionic compounds. Well. How can we recognize that we are in front of a binary compound? First of all, the cation is a metal. Remember that the metals are to the left of the zigzag line in the periodic table. And we use the name of the cation as it is in the periodic table. The anion is a nonmetal, so it is to the right of the zigzag line in the periodic table. How are we going to name an anion? Well, we change the ending by "-ide". For example, you know that sodium is a metal, so we call it as it is in the periodic table. And chlorine is a nonmetal, is to the right of the zigzag line. So we change the metal will have the same name, and the non-metal we are going to change the ending by "-ide". Remember, the ionic compounds are made of a metal and a non-metal. So it's very simple. This compound, as you can see here, is sodium chloride. But what happened is the first element, the element to the left, is not a metal. Well, in this case, what we are going to do? We are going to use prefixes to say the number of atoms. If there is only one, we say mono. But we use this prefix only for the anion, not for the cation. Di, if there are two. Tri, if there are three, etc. The first element always keeps its name, and the second one, as I told you before, changes the ending by "-ide". Well, here we are in front of a covalent compound. The covalent compound is made by a nonmetal plus a nonmetal. The first element will have the same name as in the periodic table, and the second one will change the ending by "-ide". This is the rule. For example, carbon and oxygen. Well, it makes carbon dioxide, and we use di because we have two oxygen, and the ending changes to "-ide". In the case that we have polyatomic ionic compounds, well, polyatomic is when the ion has more than one element. For example, this is the case of this one, CO3 -2 is carbonate, and the first element in the compound has the same name as in the periodic table. Then it will be calcium carbonate. Let me stop here into the difference between ionic and covalent compounds. Ionic compounds is when one element loses electrons and the other one gains electron. But when we are in front of covalent compound, they don't lose or gain electron. They share electrons. That's the difference between ionic and covalent compounds. The other example that we have is when the metal that generally are transition metals, they have more than one charge. This is the case of iron. Iron can work with +2 or +3. According with this, we made the difference. Well, first we write the name of the cation, that is iron, and then into parentheses using Roman numerals, we type the charge of the cation. For example, iron here in these compounds works with 3. How do you know? If you have only the formula that iron works with 3. Oh, there is a rule that this 3 goes as the charge of the cation, and this is the charge of the anion, but negative. Then here you can see, according with the formula, that iron is iron 3 using Roman numerals or numbers, sorry. And remember, the second element always ending in "ide". Well, acids can be divided into binary or oxyacid. If it is a binary compound, well, for example, is when you have, if it is when you have, for example, hydrogen and an anion. The anion is a non-metal. In this case, when we have hydrogen and a non-metal in the liquid or aqueous state, because if it is in the gas state, it will name as a covalent compound. And then we have to say hydrogen chloride. But if it is in aqueous solution, it's a gas dissolved in water, then it is a binary acid. And we begin always saying hydro. Then we use the root of the name of the anion and always ending in "ic". In this case, the root of this anion is chlor. From chlorine, yeah? Then the name of the binary acid is hydrochloric, and we add the name of acid. hydrochloric acid. What changes from one to another? Oh, the anion. If here we have iodine, then we say hydroiodic. If we have fluorine, then it's hydrofluoric, and so on. But if we have an oxacid, it's because we have a polyatomic ion. Then, if the polyatomic ions ends in 8, the acid will end in -ic. For example, sulfate, sulfuric acid. If it were H2SO3, then the name of this polyatomic ion is sulfite. Sulfite. Then we change the ending "ite" by "ose." Then we say sulfurous, and we end by acid, sulfurous acid. Then here you have the rule 8 -ic, 8 ose. You can learn this rule by heart. 8 by -ic, A by -ic, 8 by ose. Here you have a table with the different polyatomic ions. You can use this table during the test. You are allowed to use it. Okay? Then here you have ammonium, that is a cation, but you have nitrate, nitrite, hydroxide, sulfate, sulfite, phosphate, carbonate, bicarbonate, or hydrogen carbonate, chlorate, chloride, permanganate, acetate, that is an organic compound, but it is very used in inorganic, cyanide, and dichromate. Well, there is an important case where an anion, for example, in this case, Cl, has different number of oxygen. According with the number of oxygen, you can use this. What remains equal? The root of the anion. If it is Cl, chlorine, then you use chlor. But if you have only one atom of oxygen, you use hypoite. If you have two, only ite. If you have three, 8. If you have 4, per and 8. And here you have another examples that are less used. But these one are very, very important because there are several nonmetals that can make 4 types of oxacids. Then, if you follow the rule of the number of atoms of oxygen in the acid, you can use this rule to name the oxyacid.